In this video, I'm going to continue about NumPy. Iterating arrays. Iterating means to go through each constituent of an array consecutively. Let's iterate a one-dimensional array. Let's import NumPy. A is a one-dimensional array. Let's use a for loop to iterate through array A. For y in A, print y. This loop iterates through each element y in array A and returns back each value one by one. Two-dimensional array A. Iterate through A using a for loop again. For y in A, print y. Similar to the previous example, the for loop gives back each value, each constituent array one by one. Let's create ARA, a three-dimensional array. Let's iterate through ARA using for loop. For y in ARA, print y. Similar to the earlier examples, the for loop iterates through the array ARA and gives back the main constituent array one by one. To get the individual values from the array, we need to iterate through each array in the dimensions. Let's use for loops to do that. There are 3 for loops and it is iterating through each element in each of the constituent arrays in ARA to yield back each value one by one. It is challenging to iterate through a high dimensional array using n number of for loops to get each constituent value. NDitor function solves such problems faced during iteration. Let's iterate through the three-dimensional array ARA just created before to get each element value. For y in np.NDitor ARA, print y. NDitor function helps to return each element's value one by one. Let's iterate through every element of a two-dimensional array, omitting 2 elements in between. In this for loop, we utilize filtering and iteration hand in hand. You see that it has iterated and got every third element. Starting from the first element, it has picked up every third element and so on. NDenumerate function does enumerated iteration. NDenumerate function can be used to get the index number of each constituent on iterating an array. Let's create a one-dimensional array AR. IX is for index and y is for the corresponding constituent. To combine multiple arrays to yield one array. Arrays are joined in NumPy on the basis of access using concatenate function. If the access is not mentioned, it is considered to be 0. Let's create arrays A1 and A2 using NumPy array function. Join arrays A1 and A2 using concatenate function. A is the combined array from input arrays A1 and A2. Let's create arrays A1 and A2 using NumPy array function. Two-dimensional arrays. Let's combine these arrays row-wise. A is the combined array of input arrays A1 and A2 after it has been combined row-wise. Stacking arrays means to place an array over another array. Let's create one-dimensional arrays A and B using NumPy array function. This is the output array from stacking arrays A and B row-wise, that is on axis 1. Let's do stacking row-wise. A1 and A2 are one-dimensional arrays. Stack function stacks arrays row-wise. Now stacking column-wise. VStack function stacks arrays column-wise. Let's do an example of the same. Let's do stacking height-wise now. DStack function places arrays over one another along the height. Splitting means to rupture the array into many arrays. Syntax would be np.array underscore split brackets array to split and number of splits argument brackets closed. A is a one-dimensional array. Here array underscore split method breaks down a one-dimensional array A into a two-dimensional array an. Let's see in Python what happens if there are fewer constituents in the initial array given the number of splits within array underscore split function. A is a one-dimensional array. Now array underscore split method is trying to break down an array an into 4 groups of constituent arrays. Since there are only 6 elements in the array A, it is not possible to actually make 4 groups of equal elements. Let's print an to find out how Python has broken down the array A. As you can see, an is an array of unequal constituent arrays. Let's break down 6 two-dimensional arrays using array split method. A is an array of 3 groups of 2 two-dimensional arrays. Let's break down a two-dimensional array into 3 two-dimensional arrays row-wise. Let's split arrays row-wise using split. A is a two-dimensional array. VSplit and DSplit resembles VStack and DStack in their functionalities respectively. VSplit function breaks down an array column-wise. DSplit function breaks down an array height-wise. Searching array, you can look for indexes in an array where there is a specific value in an array using where method. A is a one-dimensional array. Let's get the index where element 41 is present in array A. Indexes 3, 5, 6 is where element 41 is present in array A. np.where method gives a tuple object containing the indexes of lookup values. Let's find indexes where there are even numbers in an array. A modulus 2 is equal to 0 implies that there is no remainder left after dividing constituent by 2. The constituent in array A is completely divisible by 2. Indexes 1, 3, 4, 5, 7 are where there are even numbers in array A. Let's find indexes where there are odd numbers in an array. A modulus 2 is equal to 1 implies that there is a remainder of 1 left after dividing constituent by 2. The constituent in array A is not completely divisible by 2. Indexes 0, 2, 6 are where there are odd numbers in array A. Search sorted method looks for an index in a sorted array where the specified value can be put in to keep it sorted. This is called binary search on an array. Let's create a one-dimensional array A. Let's find the index in array A where 38 can be inserted. 2 is where element 38 can be inserted in array A. The search sorted method starts to look for the value from the left to retrieve the index when the specified value would not be greater than the successive value. np.search_sorted gives the index from the left side. We can pass side argument to the same method to retrieve index from the right side. Index 3 is where element 38 can be inserted in array A from the right side. In order to determine index where multiple values can be inserted in an array, insert an array with those values to the search sorted method. Let's create a one-dimensional array A using np.array. Similar to the previous examples, let's find the index where the values 13, 15, 17 should be put in the array to maintain the sorting. X is an array with the needed indexes 1, 2, 3 where the values 13, 15, 17 can be inserted in array A. Thank you for watching the video. Please subscribe to the channel for more videos on data analytics and business.